One bonus thing that we're going to cover here is hypothesis testing in cartoons. This is based off the excellent cartoons by Allison Horst, which I'll link to in the slides. So we're going to start here. If we have random samples that are drawn from populations with the same mean, then it's very likely that the two sample means will be close together. So you grab them from the same population, they're probably very similar. And it's less likely, but always possible, that the sample means will be far apart, because we're sampling from one or more populations. Each sample will probably be within that population itself. So you might look at this continuously as curves or as histograms. So we've gone through both. We're going to go with curves moving forward. In other words, the more different the sample means are, the less likely it is that they were drawn from populations with the same mean. So if you look at two distributions that have very different means, you might ask, do you think that they came from populations with the same mean? And it's possible, it's always possible, but it's unlikely. So for our two random samples, we ask, what is the probability of getting two sample means that are at least this different, the delta between the means, if they were actually drawn from populations with the same mean? That's the null hypothesis. It's the assumption that it's the same mean. And so you calculate the probability that you get these two values from a single population, and that allows you to guess whether it's likely that they're from the same one or not. So for example, and so this is our p-value. The probability of getting two sample means they're at least this different, maybe more, if they're actually drawn from populations with the same mean. So if a two sample test for these samples yields 0.03, that means there is a 3% chance of getting means that are at least this different if they're drawn from populations with the same mean. And here's a diagram of them with the corresponding levels of overlap for various values. The higher the p-value, the higher the probability that they came from the same population. The lower the p-value, the more unlikely it is that they came from the same population. So one question you might ask is, when do you have enough evidence to say there is a significant difference? And the answer is when our p-value is below our selected significance level, alpha, usually, but not always, 0.05, which, like I said, is a bit arbitrary. Which means if the probability or p-value of finding at least our difference in sample means, if they're drawn from the same mean, that's our assumption. If it's less than 5%, then it's enough evidence for us to decide that they're probably from populations with unequal means. A type 1 error is when you get those two samples from the same mean. So you got these two wild child samples, but they both come from the same population distribution. And a type 2 error is when you get those sort of more extreme sample values from two different populations, or populations with different means, but they look like they're very similar. And remember, it's not just about the p-value. You got to look at everything else. You got to look at the effect size, the context, data visualizations, etc., correlation. And so a lot of studies and a lot of reports will focus on that p-value, and it's all about that significant difference. No, you need to have a sense of that context, and ways that you can do that might be through effect size, confidence intervals, visualizations, and just giving the numbers. The key takeaways from this lesson are: statistics give us formalized error. That's the whole point of doing stats. An outcome, a specific observation or predictive value, is the model plus that error. And so you can model it as error coming out from this model. And confidence intervals are an important way to interpret and communicate error. Statistical significance is not the same as practical significance. P-values only tell us if we think the samples don't overlap. We also need to know practical significance and context, so like actual values. So it's important to know how to use confidence intervals and provide that context. Thank you so much. I'll see you next time.